Alright, hell yeah. So what we have here is a logic problem. Now this is Mind Your Decisions. He does this, and it's Presh Talwalkar. Does a very good job. And but it says, can you solve the prisoner's random hat puzzle? So I'm going to say, let's do it. And I'm going to use this picture. So that said, I'm going to slow roll this problem. So you don't even need to stop the video and try it for yourself. That's going to be the cool thing about this, because I don't think anyone likes puzzles. I don't think anyone likes especially logic puzzles because they're very tricky. But what we're going to talk about is we're going to go through this and try to get some idea of skills that we can use from this puzzle that maybe we can apply to other logic puzzles. And for this, I haven't even done this one 100%. I just got to the point where I'm just like, oh, no duh. Or like I see how it's probably should be taught, and maybe it's not. So hell yeah, let's do it. So anyway, and this reminds me of like what logic puzzles are. They're just like, hey, if this is my starting point, you know what I mean? Can I just go in one direction? Probably not. I can probably go two different directions. Okay, hell yeah. And so what I'm going to relate this problem to is like, almost like systems of equations. I think we're all used to linear algebra, like y is equal to 2x plus 1, and then y is also equal to, 3x minus 2. Is there a solution that satisfies both? And I don't even know. Like, how would you even do this one? Like, for this, like one technique that I use. Sorry, I'm going to go on a tangent here. One technique that I use is just, hey, throw in 0. If I throw in 0, I'm going to get 1 and negative 2. Okay, now I just throw in like 10. Okay, if I throw in 10 here, I'm going to, well, what should we do? Let's throw in, typically I do this 0, 1, negative 1. So let's throw in 1. If I throw in 1, I get 3. And if I throw in 1 right here, I'm going to get 3 minus 2. Okay, so 3 minus 2 is 1. Okay, so finally we're positive here, but this is still bigger. This is still bigger. This is still bigger. Is there any... What if I threw in a negative 1? I would have negative 5 right here. So I would have negative 5. And up here, if I threw in negative 1, I would only have... this one's still going to be lower. I don't know. Is there a solution to this one? Who knows? This is yeah, I don't know why I'm freaking out, but we shouldn't be going on this tangent. We want to do this problem. But it shows you like, yeah, so let's continue. If I do negative 1, I'm going to get negative 5. And if I do negative 1, I'm going to get still a bigger number. It's just going to be negative 2 plus 1 is just negative 1. And so this is still a bigger number. What I'm trying to get is like this a bigger number. So if I do throw in 10 here, well, hell yeah. I mean, I don't know. I started with 10. And so if I throw in 10 here, I get 28. And if I throw in 10 here, I get 21. So obviously this is now bigger. So hell yeah. So all that means is there's going to be a solution between 1 and 10 because it switched. You know what I mean? So... Anyway, I don't know why I did that little tangent. I'm kind of bummed that I even did that. But anyway, but it just kind of shows you like how can we take this problem and make a systems of equations. And I'm just going to say for this one is like we even just get one equation. Maybe we're shooting for like 2 equations, 2 unknowns. But even just to nail down one equation is... What was an important aspect of this problem. Okay, so now we're going to do it. So basically you have these 5 hats. Randomly you can put them on these prisoners' heads. So this prisoner could have a red hat or a blue hat. This prisoner, same thing. Cool. And then they're lined up. So, this guy can't see behind. This guy can't see the top, and then each of them can't see the top of their head. They can't just kind of look up and see what color hat they're wearing. Okay, hell yeah. So, yeah, but it's just fascinating. So keep this in mind of like 2 equations, that you're trying to solve simultaneously. But hell, I'm going to reiterate. It's just like, yeah, still just focus down one path. So like right here is we're gonna be branching. Okay, hell yeah. So But then, and then one aspect of this problem is that this prisoner can either say, because they're asked a question, do you know what color hat is on your head? So they can either say, I don't know, or I do know. Those are the only two responses that the prisoners can say. And cool. So with that, let's dive in. All right, hell yeah, new battery. And we can even go back to this one. This is fascinating me. It's probably more exciting than this actual problem. Is because I could throw. So the first thing I did was throw in 0. And that meant this was 1 and this was -2. So this top equation was bigger. Then I threw in 1 and freaked out because that just means we had 3 and then we had 3 minus 2. This is -1. The top is still bigger because we have 3. But then if I throw in 2, this becomes 4 plus 1. The top is 5. And the bottom, if I throw in 2, is 6 minus 2. Well, that's 4. So we're getting close. So now if I throw in 3, so we already did 2. But if I throw in 3 now, I'm going to have 6 plus 1 is 7. 7 up top. And then the bottom is going to be 9. So 3 times 3 is 9 minus 2. That's 7. So hell yeah. So, I mean, typically what I would want, so that is the solution. X is going to be 7. If x is 7, these y's are equal. Cool. And if x is 7, no. I said, holy hell. So if x is 3, y is 7, and this coordinate 3, 7 is a solution to this equation. But sometimes I like to over jump, that's why I did 10. That's why I said the solution was somewhere between 1 and 10, so we kind of got that. If I chose 4, I would have 2 times 4 is 8 plus 1 is 9, and then I would have 2 times 3 is, so I'm doing 4. 3 times 4 is 12 minus 2 is 10. So the bottom one is bigger, and then, so let's go back to throwing in 2. If I throw in 2 right here, I'm going to have 2 times 2 is 4 plus 1. I would have 5. And then here's going to be 2 times 3. That's 6. 6 minus 4. That's going to be 4. So the bottom is less. So hell yeah. So that's where I like that idea of like guess and then check. And I don't know if this is going to come up in this problem at all. But it's just a different tactic. No one does it that way. I should just make a separate video of exactly what I just did right there, because it's very useful. No one does this, but when your equations are hella complicated, maybe, and sometimes it's just like, well, throw in 0, see what you get. Throw in 1, see what you get, and maybe even see what direction you're tending towards. Booyah. All right. So here, this prisoner can say two things. They can say I don't know, or they can say I do know. So let's stick with the I don't know first, because in the video that's the first thing this prisoner says. So what would be a combination that this prisoner doesn't know? You know what I mean? If the prisoner sees 2 red hats, well, there's an extra red hat out there. So the prisoner this prisoner 1 could have a red hat, right? So if if one said, should I call him prisoner 1? If prisoner 1 sees 2 red hats, prisoner 1 still doesn't know the hat on top of his head. Cool. And this is a men's prison, so everything will be he, him. Okay, so hell yeah. Yeah, okay, so let's switch it up. Let's say this hat's blue and this hat's red. Does prisoner 1 know what hat's on top of his head? Now we're just we're doing that same method here. It's just like, well, just try something. And so a blue hat here, a red hat there. These are the 3 combinations that prisoner could have. And no, the prisoner 1 would not know what's on top of his head. But so, and it's that jump that you're just like, oh, you know what I mean? So the first and maybe obvious thing that you could probably see is like, if this prisoner sees 2 blue hats on prisoner 2 and 3, the only 2 blue hats available, then does prisoner 1 know the color of his own hat? Hell yeah. And prisoner 1 would say, I know. Cool. So that is the route that I would actually start. You know what I mean? To be like, oh, what makes something actually known? So we can see that if prisoner 1, again, sees these two blue hats on 2 and 3, prisoner 1 would just say, I know. Okay, sweet. And then it would be done. And then if prisoner 1 said, I know, prisoner 2 would, so doing with logic, prisoner 2 would be like, whoa. If prisoner 1 said he knew, the only way prisoner 1 would know is if both me and prisoner 3 has blue hats. So this person would also say, I know, and then this person would say, I know. So that's kind of one combination that for sure just easily goes. Okay, so, but now, let's say this, let's just make up another little scenario. Let's say, and I think the most likely thing to do, it might not be obvious, none of this is to put a blue hat on prisoner 3 and a red hat on prisoner 2. So prisoner 1 still has to say, I don't know, because there's still a blue hat that he could have on top, and a ton of red hats, you know what I mean? So, but then prisoner 2 sees that prisoner 3, so we're done with this guy. Prisoner 2 sees this blue hat and knows that if prisoner 2 was wearing a blue hat, again, prisoner 1 would have said, I know, right off the bat. So in that scenario, if prisoner 2 sees a red hat, if prisoner 2 sees a blue hat on prisoner 3, even just one blue hat, I mean, that's all prisoner 3 can have is just one blue hat, prisoner 2 would say, I know. Because, so just even from that, I don't know, that is actually fascinating. Even that almost gets you there. Like, doesn't it? Doesn't it? I mean, I know we're just going down, like right now we're just going down the scenario that these blue hats are out here, and what's the combination they could be on? These blue hats, and we're just saying these blue hats could either be on 2 or 3, both, and then prisoner 1 would say, I know. Another question came up in my video, is just like, well, how do you make things not messy? Because a lot of math and physics, especially math, it's like juggling. You know, how many things can you juggle in your head? Like, I don't know, like, you get better at juggling, but still, I consider, like, I'm a slow roller. You know what I mean? We have to kind of go back to the beginning all the time. So again, these 2 blue hats, 2 and 3, prisoner 1's going to say, I know. Cool. You know, that's the most obvious thing that can happen. If this person says, I know, this person's going to say, I know, and for sure this person's going to say, I know. So all 3 would say, I know. But then you get into this case of, like, we're still going to say there's a blue hat out there. This person's going to say, I don't know. And the most obvious is for this person to see a blue hat on person 3's head. Because in that case, then it also is kind of this other fast solution. Because so prisoner 2, again, sees a blue hat on prisoner 3. But knowing that prisoner 1 said, I don't know, so I mean, we're making up our own scenario here, that means prisoner 2 does not have a blue hat. Because if prisoner 2 sees a blue hat on prisoner 3, and has a blue hat on his head, prisoner 1 would have said, oh, hell yeah, I know what hat's on my head, because the only 2 hats available are right in front of me on these 2. And I think that's a more important part of this problem, because the whole setup is that you have 3 prisoners and they can all get out of jail if they and they're all logicians, you know, so they should be able to do this pretty fast, and it's totally random. Like, you should be able to put these hats. Every combination of hats on these heads should grant a solution, or it does, and that's cool. But with this combination, the I don't know, and then I know is probably the trickiest. You know what I mean? Because we just showed that if if these both blue hats are on 2 and 3, going back to juggling, back to the basics, if prisoner 1 says, I know, then hell yeah, this person knows, this person knows. And then we jump to the next most convenient case, which is prisoner 1 saying, I don't know. So the only way prisoner 1, I mean, there's a lot of ways prisoner 1 could say, I don't know. Like one prisoner, again, we could say, if prisoner 1 sees 2 red hats on 2 and 3, prisoner 1 still doesn't know if he has a red hat. Just, doesn't know. So, and we've talked about that. So it's always good to go back to the beginning and being like, oh yeah, the only way prisoner 1 is going to say, I do know, is if prisoner 1 sees these 2 blue hats on 2 and 3. Hell yeah. Okay, and then so back, like just juggling, you know what I mean? What's the throw one more ball in your hand. The next simplest is to throw a blue hat on prisoner 3. And then say prisoner 1 doesn't know. And so if prisoner 1 doesn't know, that means that he only sees a blue hat on one of these people. It's going to be on 3. And if that's the case, prisoner 2 does know, because prisoner 2 knows that his hat is red. And I think that's, like, I know I'm slow rolling this, but yeah, it's just very fascinating. Go back to the beginning. Set up the most obvious thing that's going to generate the most quickest answer. And then what's the second most obvious thing? So we threw a blue hat on 3. This prisoner 1 didn't know. Prisoner 2 knows. And so then could prisoner 3 for sure know? Because prisoner 3 is listening, and so if prisoner 1, so even if act like you're prisoner 3, because you have to be listening to what prisoner 1's answer is. So if prisoner 1 says, I do know, let's go back to that one. Well, there's only 2 hats out there, and then so prisoner 3 knows that his hat is blue. But if prisoner 1 says, I don't know, it sets up this scenario where maybe prisoner 3 is thinking my hat is red. And he's thinking, well, maybe my hat is red or blue. And then this prisoner is thinking, well, maybe prisoner 2 hat is red or blue. I don't know yet. But prisoner 3 does have one piece of information, that both prisoner 2 and prisoner 3, both of their hats aren't blue. So when prisoner 2 says, let's go back to the easiest thing. Prisoner 2 says, I do know. So prisoner 1 said, I don't know. Prisoner 2 said, I do know. That means that prisoner 2 sees a blue hat and knows that his hat's red. And then prisoner 3 should pick up on that and be like, okay, hell yeah, my hat's blue. Hell yeah. So, and that's kind of cool, because I'm still not going over the solution that generates the I don't know, I don't know, I do know. Alright, so now we're just right at that cusp of like, okay, we did the 2 most obvious. We put, again, juggling. Easiest thing, put these 2 blue hats here. I know, I know, I know. The next obvious thing to do is just throw the blue hat here. It's going to be an I don't know and I know, and then for sure an I know. Okay, hell yeah. But let's throw the blue hat here. So prisoner 1 is going to say, I don't know. And then prisoner 2 is going to see a red hat and say, I don't know. So there you go. So if prisoner 2, in the scenario that prisoner 2 is wearing a red hat, a blue hat. So prisoner 2 is wearing a blue hat. That's what we're doing right now. Prisoner 1 doesn't know what hat. Prisoner 1 could have a blue or a red hat, you know what I mean? Prisoner 1 just doesn't know. All prisoner 1 can see is that there's a blue hat here and a red hat here. So prisoner 1 does not know if he has the other blue hat on or the red hat. Okay, hell yeah. But then when prisoner 2 says, I don't know, I don't think you should focus on that. I think you should focus on what if prisoner 2 said, I know. If prisoner 2 says, I know what color hat mine is, it's because prisoner 3 has a blue hat. Now, is that the only scenario Because what if prisoner 1 has a blue hat on? Yeah, it's just so fascinating that it's just like, how does prisoner 2 again know that he doesn't have a blue hat? It's because prisoner 1 would have said, no, this is a weird one. Okay, so we're going to put the red hat here and the blue hat on prisoner 2. And prisoner 1 is going to say, I don't know. Yeah, this is a bizarre one. Because if prisoner 1 said, I do know, both these are blue. But because prisoner 2 sees a red hat, he can't say that, prisoner 2 cannot say whether his hat is blue or red. Because you also have the combination where prisoner 2 and 3 could have red hats on top of their head. And prisoner 1 would say, I don't know. And then prisoner 2 would say, I don't know. But yeah, we have to go back to that. The fact that prisoner 2 could have said, I do know, after prisoner 1 said, I don't know. So, yeah, it's just really fascinating that prisoner 1 could have a red hat, prisoner 2 could have a red hat, prisoner 3 could have a blue hat. But if prisoner 3 has a blue hat, prisoner 2 knows his color of his hat right away after prisoner 1 says, I don't know. So that's fascinating. That is the interesting case where I like putting a blue hat on prisoner 2. Because prisoner 2 can't tell what color a hat he has. Oh, no. That was the scenario where the blue hat's on prisoner 3. If the blue hat's over here again, yeah, that's a fascinating one to go back to. And I like this video because it's like juggling to me. It's like, how many concepts in your head can you juggle? That's why some of these logic problems you'll have to like chart out. And I don't even know. I thought we could do this using equations. I have no idea, just because I barely solved this. Okay, hell yeah. So yeah, like I like the idea of juggling. Going back to these two blue hats, prisoner 1 would say, I know. If the blue hat's here and the red hat's here, prisoner 1's going to say, I don't know. But prisoner 2 is going to be like, oh, hell yeah. He would have said, I do know if I had a blue hat. So prisoner 1 knows his hat's red. Cool. And because prisoner 1 says, I know, prisoner 3 is going to be like, I know my hat's blue. Because of that first case. Because if prisoner 1 said, I do know what color hat I have, it's because prisoner 2 and 3 already have the blue hats. So if prisoner 1 says, I don't know, then there's two cases of why prisoner 1 doesn't know. It's because both of these hats are red, and then prisoner 2 would also have to say, I don't know. So then that's why prisoner 3 can say, I do know, because his hat's going to be red. Because if prisoner 2 says, I do know, because that's the other thing prisoner 2 could say, after prisoner 1 says, I don't know, the only way that happens is if prisoner 3 is wearing a blue hat. There's no other combination that prisoner 2 can say, I know, without prisoner 3 having a blue hat. So let's go over that. So if all three have red hats, prisoner 1 says, I don't know if I have a blue hat or a red hat, because I only see two red hats out here. And I could either have this third red hat or a couple of those blue hats. Probably I got a blue hat on. I just don't know. Okay, hell yeah. Prisoner 2 knows, again, let's go back to juggling. Prisoner 2 knows that if prisoner 1 did say, I know, it's because he already sees both blue hats. And then it's hell yeah, hell yeah. Everyone knows. But because prisoner 1 said, I don't know, then we kind of go down the spider web. Prisoner 2 just sees another red hat. So that's still inconclusive. You know what I mean? because prisoner 2 knows that he could also have a red hat on, see a red hat, and knows that prisoner 1 could be wearing a red hat and he just doesn't know it. So prisoner 2 doesn't know if prisoner 1 has a red hat or blue hat. That's why he said, I don't know. And prisoner 2 doesn't know if he's wearing a blue hat. The only way prisoner 2 would have said, I know, after prisoner 1 said, I don't know, is if he saw a blue hat on prisoner 3. So prisoner 2 is going to say, I don't know. And that's the case where all three are wearing red hats. And prisoner 3 is going to be like, oh, hell yeah, I do know. Because if I was wearing a blue hat, prisoner 1, sure, he could have said, I don't know. Because all he sees is one blue hat. And he knows that if prisoner 1 saw both blue hats, he would have said, I know. And then, but if prisoner 3, if he knew he was wearing the blue hat, or, if he sensed it, prisoner 2 would have said, oh, hell yeah, I do know my color. It's red. Because prisoner 1 said, I don't know, means they're both not wearing blue hats. Prisoner 2 might be wearing a red hat. And he would know that. And hearing that, prisoner 2 said, I know, prisoner 3 would be like, oh, hell yeah, I'm wearing the blue hat. So that's the scenario where all three, so now we're going to do this, all three are wearing red hats, I don't know. Sees a red hat, I don't know. And then that means, yeah, let's talk about that one again. So all three are wearing red hats, doesn't know. Doesn't know. The only way prisoner 2 could know is, again, if prisoner 3 was wearing a blue hat. Then he would have said, I know. Prisoner 3 is picking up on that and being like, oh, he would have said, I know. But he didn't. So that means prisoner 3 is wearing a red hat. All right, hell yeah. And I think that's it for this one. I'm sorry I didn't do it. I thought you could do it with equations, but maybe not. But I thought it was very useful to, like, hey, pick the combination that is just the hella I know. So that's where these two are wearing blue hats. So now I'm going to go over and make sure we have covered every combination. So let's cover the combination where a blue hat is on prisoner 1. That's where it doesn't matter, because if we take this blue hat and put it on prisoner 1, and then both the red hats are here and here, prisoner 1's going to say I don't know. Prisoner 2 doesn't see a blue hat, so he's going to say I don't know. And again, prisoner 3 is going to know his hat's red. Does that make sense? Because if prisoner 2 said, I do know, the only way he could have said I do know is if he sees a blue hat. That's kind of cool, because if he sees a blue hat, prisoner 1 would have said I know if prisoner 2 had a blue hat. And, but he didn't. So there you go. So, doesn't know, but prisoner 2 also doesn't know, because it wasn't that special case where there was a blue hat there, and prisoner 1 said, I don't know, but prisoner 2 could have said, I know. So 2 I don't knows means that this guy's hat's red. So that was a blue hat here, and then 2 red hats. Okay, hell yeah. So now let's put the blue hat on 2 again, and then we're going to do 2 red hats here. Well, it doesn't even matter. Prisoner 1 could have a blue hat, prisoner 2 could have a blue hat. Prisoner 1's still going to say, I don't know. Prisoner 2 is still going to say, I don't know. And so let's talk about that. You know what I mean? If prisoner 1 says, I don't know, that means that both these prisoners do not have blue hats. And if prisoner 2 sees a blue hat, he would have said, I know. So the fact that prisoner 2 doesn't say, I know, this hat's got to be red. Alright, so that's the case where both these blue hats are on 1 and 2, and prisoner 3's is red. Okay, hell yeah. Is that the only combination? So 1 and 2 could have both blue hats. We just covered that. Prisoner 1 could have a blue hat, and prisoner 2 could have a red hat. I don't know. I don't know. That means this hat's red. Because if this one said, I don't know, well, that means that both of these aren't blue. And if this person said, I do know, it's because he sees a blue hat. But he didn't said, I don't know. So that's the case where you just have one blue hat on 1, and it doesn't even matter. That blue hat could be on 1 or it could be on 2. So there you go. And then there's that's the case. That's all 3 cases where these blue hats could be both on 1 and 2. or a blue hat on 1, a red hat on 2, or a blue hat on 2, red hat on 1. Both, they're still going to say the same things. I don't know, and then I don't know. The only way any of these two people say I know is if well, this guy can say I know if both blue hats are out in front of him. This guy can say I know is if he hears an I don't know and sees a blue hat on prisoner 3. Then he knows his hat's red. And again, if prisoner 1 says I know, well, everyone knows. You know what I mean? Right off so it'd be an I know, I know, I know, or it could be, and then the combination. So the spider web happens when prisoner 1 says I don't know. Well, then you're waiting to see if prisoner 2 says I do know. And so we've covered that. The only way prisoner 2 can say I do know is if prisoner 3 is wearing a blue hat. And he doesn't. So that for sure means prisoner 3 is wearing a red hat. Hell yeah. Alright, so now I'm going to kind of review. Because I want to go to the hardest case. But let's start out with the easiest. The easiest was 2 blue hats on 2 and 3. Prisoner 1 would have said I know. Because there's only 2 blue hats out there and he sees them both. So prisoner 1 for sure knows his hat's red. If he says I know, prisoner 2 knows because, well, both prisoners know because the only way prisoner 1 could know his hat color is if both these are blue. So it'd be an I know, I know, I know. Alright, so then the hardest case is if all 3 hats are red. And that's why I don't think you should go there first. I think you should do the next easiest case, which is for sure put the blue hat on 3, have prisoner 1 says, I don't know. And so that means prisoner 1 does not see 2 blue hats. That's all you know right there. But prisoner 2 does see a blue hat. So then you have that case where, well, prisoner 1 would have said I know if prisoner 2's hat was blue as well. But he didn't say that. So prisoner 2 would know his hat's red. So that's the next easiest case to go to. Alright, so now let's bring it home and put all 3 red hats on 1, 2, and 3. Prisoner 1 is going to say, hey, I don't know. Because he sees 2 red hats and there's a 3rd red hat. His hat could be red or blue, doesn't know. Prisoner 2 sees a red hat in front of him and he doesn't know. But he has this, but you need to think, even though this is the hardest scenario, you got to go back and juggle that easiest. Prisoner 2 heard prisoner 1 say, I don't know. The only way, so prisoner 2 is going to be thinking in his head, why would, or how could prisoner 1 have said, I know? And yes, he could have. And the only way he could have said, I know is if he saw 2 blue hats in front of him, but he didn't. He didn't see 2 blue hats. So then he's going to look at prisoner 3 and see a red hat. Does that mean prisoner 2 is wearing a blue hat? No. Because he could also be wearing, all 3 could be wearing red hats. But prisoner 2 is in this scenario where he still does not know. He has to say, I don't know. Because he doesn't have that special case. The easiest case, if prisoner 1 said, I do know, is if they were both wearing blue hats. But he didn't say that. So prisoner 2 is thinking, well, maybe I'm wearing the blue hat. But I'm looking at a red hat. So, that's a possibility. But still, you still have, prisoner 2 knows that he could be wearing a red hat and staring at a red hat. You know what I mean? And so he has to say, I don't know. So how do you go from that and then prisoner 3? That's the hardest case. Like, how do you just go from that and say, prisoner 3 knows? Well, I think you have to go back to prisoner 2 and be like, well, could prisoner 2 have said, I know? And prisoner 2 could have said, I know, even after prisoner 1 said, I don't know. And the only case that is going to happen is if prisoner 3 is wearing a blue hat. And let's talk our way through that one again. And so prisoner 3 has to ask that same question probably to both prisoner 1 and prisoner 2. Prisoner 3's got to be like, hey, if prisoner 1 said, I know, that means that we're both wearing blue hats. He already saw them. But he didn't. He said, I don't know. So maybe there's a scenario where I'm wearing a blue hat and prisoner 2 would see that I'm wearing a blue hat, and then would say, I know what color. That's the scenario that prisoner 2 could also say, I know what hat I have on, because yeah, this is such weird juggling. It's prisoner 2 knows his hat's blue because he sees a red hat on prisoner 3, and he knows that prisoner 1 would have said, I know, if both of these hats were blue. I think we skipped something, but yeah. So prisoner 2 didn't say I know, and so oh yeah. So we're going to the fact that prisoner 2 said I do know. So prisoner 2 does see a blue hat. But prisoner 2 knows that prisoner 1 said, I don't know, and would have said, I do know. Prisoner 1 would have said, I know, is if prisoner 2 was wearing a blue hat and sees a blue hat on prisoner 3. But if prisoner 2 sees that blue hat and hears prisoner 1 say, I don't know, prisoner 2 is like, hell yeah, I know what color hat mine is. So that's just kind of fascinating. And I guess there's only one scenario there that happens. There's only one scenario where all three say, I know. Yeah, that's the two blue hats here. There's only one scenario where prisoner 1 says, I know, and then prisoner 2 says, I know. That means 3 has a blue hat. So that's the one we covered. But if prisoner 2 says, I don't know, then that means that there is a red hat here. And then working backwards, and then we covered all scenarios where, hey, both of these blue hats are on 1 and 2. Still, I don't know, and then I don't know. One hat is on 1, and then this one's a red. I don't know, because he just sees 2 red hats, and he knows that he could have a red hat or a blue hat. We're putting a blue hat on him. And then this person doesn't say, this person also says, I don't know. And then put the blue hat here and the red hat there. I don't know, I don't know. And then put 2 red hats. I don't know, I don't know. So all of those scenarios are where prisoner 3 has that red hat. And we put it on there, you know what I mean? So that's another way of working backwards. We put a red hat on prisoner 3. And what would prisoner 1 say? I don't know. Because it doesn't matter what color hat prisoner 2 has. If prisoner 3 has a red hat, prisoner 2 could have in both scenarios where there's a red and blue hat here, prisoner 1's going to say, I don't know. No, that's not, yeah. Sorry, this is weird juggling. Yeah, if prisoner 3 has, I should have little cutouts, you know what I mean, but my videos aren't that good. Anyway, so we put the red hat on prisoner 3, and then we put either color hat here. Prisoner 1 always has to say, I don't know. And prisoner 2 always has to say, I don't know. So hell yeah. So that is very fascinating. So I think from this logic puzzle, I thought I was going to be able to apply it to systems of equations, and I think I struck out on that chord. But it's just fascinating. I think I did learn one thing, doing the slow roll process or the juggling process, is it was really easy for me to see, it was easy. This problem wasn't easy at all. All logic problems suck. And so here, I'm going to have a little announcement. It's just like, if you want to do puzzles and you don't want spoilers, if you don't want to just go for the solution, because this, I was so tempted. I was right on the cusp last night. I did this right before bed, and I was just like, I should be able to do this. And then I wasn't. And then I was just like, so, you know what I mean? I got to where this picture was, and then here's the solution. And I was just so tempted to go to the solution. And this was an interesting one, because even last year, I looked this problem up, and I totally forgot all about it. You know what I mean? So it's just fascinating that there still is hope to look at the answer of a puzzle and then forget how to do it, so then you can do it fresh, once you forget how. So yeah, and then just have different approaches, because I think having, figuring out how to make an approach. So after this, I'm going to sit down, because there's another one where there's a 4th person here, and I don't know how that one works, but I'm really curious to see if I can do that one. So to recap, it was really easy to put both blue hats here and ask the question, like, could prisoner 1 say I know? And yes, he could. Prisoner 1 could say I know if both these blue hats were right here. So that was just so fascinating to also just say, hey, let's just pick a color for prisoner 3 hat, and then what would prisoner 1 say? And they would say these things. I don't know. I don't know. In all scenarios, you could have any other combination of hats on prisoners 1 and 2. As long as prisoner 3's hat's red, you're always going to get these responses for prisoner 2. Now, from this logic problem, I don't think I would have ever done that. You know what I mean? Just say, hey, I just want to pick a scenario and then stick with it and be like, are those the things that are going to be said? And then that would be like the working backwards. You know what I mean? Kind of go for the solution and then kind of work backwards. But I think we did it. We chose the easiest solution and then probably that second easiest. The second easiest was if prisoner 3 had a blue hat, prisoner 1's going to say, I don't know. Prisoner 2 is going to say, hell yeah, I do know. And we kind of ran through all the scenarios. The second prisoner 3 hears an I know from behind him, that just means that he for sure knows his hat. And so we covered that. If prisoner 1 says I know, it's because both of these people are blue hats and both of them know right away. I know my hat's blue. Hell yeah. And if prisoner 3 has a blue hat and you hear an I don't know but then an I know, hell yeah, prisoner 3 knows his hat's blue. And then the third scenario, I don't know, and then prisoner 3 knows his hat's red, even though in that scenario, prisoner 3 just knows the color of his hat. So let's talk about that, because that's all prisoner 3 knows. Prisoner 3 knows, well actually, let's slow down, and I think we got a couple more minutes, hell yeah, before my battery runs dead. Prisoner 3 knows his hat's red, but also knows 2 other things. Prisoner 3 knows that, well, no, I don't think prisoner 3 knows much of anything. Prisoner 3 knows that prisoner 2's hat could be blue. That's a scenario, because prisoner 1 said, I don't know. But prisoner 2 could have a red hat, and prisoner 1 would have said, I don't know. So hell yeah, so this could be red or blue. And if we have this red hat here, hell yeah, you have all combinations. You know, this could be 2 reds, 2 blues, a red and a blue and a red. And all those scenarios, prisoner 1 and 2 are always going to say, I don't know. So even though prisoner 3, so that'll take it home. Because even though prisoner 3 knows the color of his hat, if you asked him to speculate, do you know anything? Do you have any shred of information about prisoner 1 or prisoner 2's color of hat? Prisoner 3 would say a flat out, I have no idea what prisoner 1 or 2. I have no shred of logic. It would be a 50-50 guess. But at that point, prisoner 3, I guess, would have the piece of knowledge that his hat's red. So prisoner 3 could say there's a 50-50 chance that prisoner 1 and 2 have a blue or a red hat. Alright, hell yeah. So thanks for joining me on this one, and that's a video.